Dear friends, welcome to our channel Hoye. Click on the subscribe button and then click on the bell icon to get more notifications. Dear students, today we will see quicksort sorting technique. As you already know, there are so many sorting techniques: bubble sort, insertion sort, selection sort, merge sort, etc. Quicksort is another sorting technique and it is called as one type of in-place sorting algorithm. In place means it will not take extra array to sort the values. It will sort these values in the same array. Whatever array we have taken in the beginning, it will use the same array to sort the values. So it is also called as in-place sorting algorithm. It is one type of divide and conquer algorithm. Divide and conquer means it will divide whole array into parts and it will do the sorting process. So it is called as divide and conquer algorithm. As we have already know about binary search technique. Binary search also uses the divide and conquer concept. The name quicksort is given by the developer since it will not take extra memory to sort the values. So they called it as a quicksort. And compared to other sorting technique, this is better. But merge sort is better than quicksort. So since it will take less time to sort the values. What is the technology behind this quicksort? It virtually divides the bigger unsorted array into smaller subpartition to sort the elements. Okay, that means it will divide one whole array into two parts. Again that two part, left part it will take, and again left part will be divided into two parts. Again it will take left part. This process will be continued till the single element exists. Okay, that type of process we will call it as a quicksort partitioning technique. And it uses recursion process to do this quicksort method. What all components we will use in the quicksort process? First one is partition. This is arrangement to take all the values lesser than pivot value. Pivot value means one important element in the array or important value in the array. That we will make the assumption. And we will take all the lesser values on the left side and the bigger values compared to pivot on the right side. That means all the values bigger than pivot on the right side, that is after the pivot element. This method is also called as partitioning technique. At the end of this partition function, the pivot element will be placed at its sorted position. That means it will be in the center position. Maybe we can see here, maybe 12, 27, 5, 60, 22. These are unsorted values. And maybe we can consider any one value in this array as pivot element. Any value in this array as pivot element. Maybe we have taken end element as a pivot element. After the partitioning technique, okay, after the partitioning process, the pivot element will be placed in the center or maybe in the position where it must be. Maybe we can see like 12, 5, 22, 60, 27. And you can see all the elements lesser than 22 are on the left side. All the elements bigger than 22 are on the right side. Okay, this technique we will call it as a partition technique. And the second component is recursion. The above partition process is executed recursively to all the virtual partitions to sort the elements in the array. Maybe to the left part, maybe to the right part. Okay, and as you already know, to stop the recursion process, we need one termination condition or base condition. Without that, doing recursion process is not possible since it will act like an infinite loop. And that is the next component, termination condition or base condition. When the array size is equal to or less than 1, then we have to stop the recursion process. That means we will take start as a beginning point, end as a end point of array. If the start value is greater than end value, we have to stop the recursion process. That means we will take one statement, if start less than end in the program, and that will act like a base condition or termination condition. Those are all things we can see later. What is that pivot is? As I said, pivot is one key element of an array. And you can make the assumption of that element. Maybe the beginning element as a pivot element, maybe the end element as a pivot element, or maybe the middle element as a pivot element, or maybe you can choose any random element as pivot element. What are the other components needed? So we need maybe the start variable to indicate the beginning point of unsorted array. We will take start as 0. End variable to indicate the end point of array. Commonly we will take end is equal to n minus 1. If n is 10, 10 minus 1, then it may be 9. P index to find the exact position of pivot element. As I shown earlier, the pivot element, if it is at the end, we have to place it at the center position or maybe at one position. And that position we will find out by using P index variable. We can also take one element as pivot element. Then the coding procedure, how that quicksort coding procedure is. Quicksort, array comma start comma end we will take in the beginning. Array is the whatever unsorted array is there that we are passing here with the name array. Start, that is the beginning point, and end is the end point. Here we have taken start as 0, end as n minus 1. If start less than end, then we will continue the process. Otherwise we will come out. As I said earlier, this will act like a base condition or termination condition. Then P index equal to partition array comma start comma end. To find the position of P index, we will use this partition logic or partition technique. P index equal to partition array comma start comma end. Then we will take quicksort array comma start comma P index minus 1. Once if you know the P index value, then there may be two arrays, left array and right array. That means two virtual arrays, left array and right array. And for the left array we will take this function, quicksort array comma start comma P index minus 1. If P index is at 5, that 5 minus 1, that means the 0 to 4 it will take. Then for the right part, quicksort array comma P index plus 1 comma end. If P index is 5, then it will take 6. If end is 10, that means 6 to 9. Quicksort array comma P index plus 1 comma end, that is for the right part. Okay, and here we can see one thing. In the left part function, the end is changing. And in the right part, the start is changing. We will see partition coding. Partition coding contains partition array, that is whatever array we have passed it from the quicksort function, then the start comma end. As we have seen in the last slide, P index equal to partition comma array comma start comma end, and that partition function is this one. P index equal to start. If the start is 0, P index equal to 0. Pivot is equal to array of end. End is 5. Then it may be pivot is equal to array of end. That means array of 4. 5 minus 1. I is equal to start. I is equal to 0. To move all the values in the array. While I less than end. This is the looping process to find out the P index position. While I less than end, then it continues. If array of I less than pivot, that means the current element is less than the pivot element, we will exchange array of I with array of P index value. And then we will increment P index position. That means we will increment P index by 1. That means we will change the P index position in the array. Then After the if, we will increment I by 1 to move to the next value in an array. Again the while continues till I is less than end. After the while, when while is over, it will come down and it takes the next statement. The next statement is swapping process. That is, it will exchange array of p index with array of end. That is pivot element. And it will return p index. That means after this partition process, we will get one p index position. By that we can place pivot element at the center and we will get two parts, left part and right part. That is the concept of quicksort. And when this partition process is over, again it will go back to the recursive function. Now we will see the whole thing by taking one example. So I will take n is equal to 5. That means the size of array as 5. That means array is with 5 elements. Here you can see 0, 1, 2, 3, 4, 12, 27, 5, 60, 22. This is unsorted array. And we have taken variables. In the program we have seen start is equal to 0, p index equal to 0 in the beginning. End is equal to n minus 1, n is 5, 5 minus 1 that is 4. Pivot is equal to array of 4. As I said, in our program we have used pivot element as last element of array. So pivot is equal to array of 4 that is 22. So 12, 27, 5, 60, 22. I and p index are pointing at 12. End and pivot are pointing at 22. Now we will see step by step how the process works. From the main function, when compiler calls quicksort array of 0, 4, that means start, end. Then in the quicksort function, it takes the first statement. And the first statement is, that is base condition or termination condition. If start less than end, in our example it is true, that is 0 is less than 4, so it is true. It continues with the next statement, and next statement is p index is equal to partition array start end. That is nothing but p index is equal to partition array 0, 4. So this is to find position of p index, which is essential part of quicksort. Next we will see that part in detail. So I have kept these things as it is. Now step 2. What that step 2 is, how it works. While I less than end, that is in the partition logic. While I less than end, that is 0 less than 4, yes. Then it takes the next statement. If array of I less than pivot, that is array of I is 12 less than pivot element is 22, 12 less than 22. Then exchange array of I with array of p index. Now I is equal to p index equal to 0. So the same value is exchanged. 12 is exchanged with 12. Okay, no changes is made to the array, but p index is incremented by 1. Then p index points to array of 1. Since 0 plus 1 is equal to 1, then afterwards it will come out from the if statement and it increments I by 1. That is I is equal to 0 plus 1. Again that will be 1. That means we can see I and p index both are pointing at 27. Now in the next step, while I less than end, again it will take the while loop again. Now 0 is incremented as 1, so that is 1 less than 4. Is it as? Yes, true. If array of I less than pivot, that is 27 less than 22, no. the condition is false. So directly it increments I by 1. That is I is equal to 1 plus 1 is equal to 2. But the P index is not incremented. Since the condition is not true, P index is still at 1. We can see here. P index at 27 only, but the I is incremented to next value in the array. In the next step, again it will take back or it will go back to the while loop. While I less than end, yes, that is 2 less than 4, yes. Then it will take the next statement. If array of I less than pivot, that is 5 less than 22, yeah, it's true. Then it will move into the true part of if statement. That then it exchanges array of I with array of P index, that is 5 is exchanged with 27. Remember, 5 is not exchanged with the pivot directly. 5 is exchanged with the P index value. That is exchange array of I with array of P index. 5 is exchanged with 27. Since I is equal to 2 and P index is equal to 1. Now P index is incremented by 1. So P index is equal to 1 plus 1, 2. Now P index points to second position of array. And then it increments I by 1 after the if statement. That is I is equal to 2 plus 1, that is equal to 3. Now I points to third element, that is fourth element, but we have started it from 0. So I is at third position. In the next step, again it continues with the while loop. While I less than end, that is 3 less than 4, yes. If array of I less than pivot, that is 60 less than 22, no. Then directly it will come out from the if statement and it increments I by 1. That is I is equal to 3 plus 1, that is equal to 4. Now in the array, I points to the fourth element along with end and pivot, but the P index is at the same position, that is at the second position, array of 2. In the next step, we can see while I less than end, again it continues, that is 4 less than 4, no. Then directly it will come out from the while loop. When it comes out from while loop, then it exchanges array of end with array of P index. That means it exchanges array of end, that is nothing but pivot element. Pivot element with array of P index, that is 22 is exchanged with 27. We can see in this one. Now 22 is in 27th place. 12, 5, 22, then 60, 27. And this process is over. While loop is over. So directly it will return the P index position to the quicksort function. So we have seen how the partition function works. The first part of partition. Now P index is returned back. Now we can say that the elements before P index are less than pivot value, what we have taken earlier, that is 22, and all the elements after it are greater than pivot value 22. We can see. This is partition logic. All the elements lesser than pivot elements are on the left side, all the elements bigger than this pivot element are on the right side. So now the whole array is divided or partitioned into two subpartitions. Like partition 1 is from array 0 to array 1, that is 12 and 5. Array 0 to array P of index minus 1. And partition 2 is from P index plus 1. P index is at second 2. P index is equal to 2. Then it is array of 3 to array of 4. Array of P index plus 1 to array of end. Again it takes the quicksort process. That means once the partition process is over, it will come back with the p index value. Then again it takes the quicksort function. Okay, we can see here quicksort array comma 0 comma 1, that is for the left partition, and quicksort array comma 3 comma 4, that is for the right partition, that we have seen earlier or maybe in the program illustration. When it executes quicksort array comma 0 comma 1, then again it executes the partition function for the below array partition, that is 0 and 1 value. Now start I p index points to 0 and end and pivot points to 1. Now pivot value is 5. Since the end value we are considering it as a pivot. Now again it goes to the partition logic or partition function. While I less than end, that is 0 less than 1, yes. Then it will move into the while loop. If array of I less than pivot, that is 12 less than 5, no. Then directly it will come out from the if statement and then increments I by 1, that is I is equal to 0 plus 1. Now I is 1. Again it will go back to the while loop. Now here we can see start p index at the same position, but I is pointing to the last value. I, end and pivot are at same position now. Again it takes while I less than end, that is 1 less than 1, no. Then directly it comes out from the while loop and it exchanges the pivot element with array of p index, that is 5 is exchanged with 12 and it returns p index back to the quicksort function. Then it will be like this way, 5 and 12, start p index points to this one, so 5 and 12 are exchanged. Okay, now we can see again the next recursive call will be quicksort array comma 0 comma minus 1. Again it will be split into two parts. So the next recursive call will be quicksort array comma 0 comma minus 1. Since the p index is equal to 0 and p index minus 1 means 0 minus 1, and that will be the new p index value, but minus 1 is not valid for end. Okay, that means it will not be executed. Then it comes down quicksort array comma 1 comma 1, that is right partition function. Since the p index is equal to 0, start is equal to p index plus 1, so end is equal to 1. As there is only one element, this will not be executed. So partition function will not be executed for both the partition or both the partition function. That is the end of left part of quicksort. As we can see, left part is in sorted order, 5, 12. Now the recursive calls are made for the right partition that I have explained in the 6th slide or 6th step. When it executes quicksort array comma 3 comma 4, then again it executes the partition function for the below array partition. We can see here start I p index points to 3 and end and pivot points to 4. And the values are 60 and 27. Now pivot value is 27. Again it takes the while loop. While I less than end, that is 3 less than 4, yes. If array of I less than pivot, that is 60 less than 27, no. Then it will not take the if part, directly it comes out and it takes increments I by 1, that is I is equal to 3 plus 1, that is equal to 4. Again, if you see the illustration, start and p index at the beginning, but end, I and pivot are at the end position. Again the pivot value is 27. Again it takes while I less than end, that is 4 less than 4, no. Then directly it comes out from the while loop. Okay, and when it comes out, it exchanges array of end, that is pivot element, with array of p index. Now the pivot element is 27. that is 27 is exchanged with 60 and P index is returned back. So start P index, you can see P index is pointing to 3 and the values are array in 27 and 60. So the next recursive call will be like quicksort array comma 3 comma 2. Since the P index is equal to 3 minus 1 is the new P index value, but 2 is not valid for end. That means it will not take this function. It will not move into this function. Quicksort array comma 4. Since the P index is equal to 3, start is equal to P index plus 1 and end is equal to 4. If there is only one element, even execution is not necessary for this part. So function will not be executed for this condition. That is the end of the right part of quicksort. As we can see, right part is in sorted order 27, 60. Now if you see the whole array, you can see one thing. All the values are in sorted order 5, 12 and this is your pivot value 22. Then on the right part 27, 60. The program code of quicksort. It contains 3 functions. One partition function, second one quicksort recursive function and third one is main function. So partition function, how it will be like hash include stdio.h, hash define, yes, we have taken one constant for the array size, yes, as 100, int partition, int array comma, int start comma, int end, int p index equal to start, p index and start are at same value, that means maybe it points to 0 in the beginning. Again we need one temporary variable for the swapping purpose. I is equal to start, I again points to the 0. Int pivot is equal to array of end element, that means end element we are taking it as a pivot value. While I less than end, as I explained earlier, while I less than end, then it will move into the while loop. If array of I less than pivot, then it will swap the current value of array with p index value, that is this process. Then p index plus plus. Okay, I have not taken any other process. Even we can call separate swapping function here, but again it confuses. So I have taken that swapping process here only by taking one extra variable. Then p index plus plus, p index is incremented by 1 and after the if statement I is incremented by 1 as we have seen in the example clearly. Then at the end of while loop it will swap pivot element with p index value. Again there is a swapping process and at the end it returns p index value back to the quicksort function. Now we will see recursive function of quicksort. How the recursive function is. Void quicksort int array comma int start comma int end. So array, whatever array you are passing, unsorted array, then int start position, int end. If start less than end, as I have said earlier, it is a base condition or termination condition. Int p index equal to partition array comma start comma end to find out the p index position. Then quicksort array comma start comma p index minus 1, that is for the left part of quicksort, and quicksort array comma p index plus 1 comma end, that is for the right part. So this is quicksort function and it only calls the partition function to find out the partition, left partition and right partition. And how the main function will be? It's very simple. In the main function we can see n value we need, I is equal to 0, we have to start from 0, array of s, we have taken s as 100. Printf enter array size, that is scanf %d ampersand n, okay, to input the n value. Then we will take all the n number of values one by one using this for statement. Then we will call recursive function quicksort with the values like quicksort the array what we have taken, then 0 that is represented as start in the quicksort function, n minus 1 that is represented as end in the quicksort function. Then it will do all the quicksort process, and at the end we will display that sorted list by using another for statement. So this is end of this quicksort illustration. Thank you for watching. All the best.